In this video, we're going to go through examples 13.9 to 13.11 in your book. You're really only going to need a blank workbook to follow along, and I'm sorry, but there's going to be a little bit of math. In these examples, we're going to do a linear programming by hand, not using the solver, but by hand using the graphical method. So first, let's go over the objective equations. So I don't like using x and y for variables because then you solve the problem and what's x and what's y. So I'm going to let J equal the quantity of Jordanelle and D equal the quantity of Deercrest. Now it's very important when we do our analysis to know which is going to be our y variable and which is going to be our x. So to match the book, Jordanelle is going to be our x variable and Deercrest is going to be our y. So from the book, the equation to maximize the profit is 50J, because the Jordanelle makes a profit of $50 a unit, plus 65D. So Deercrest makes a profit of $65 a unit. Now, in the absence of any constraints, which we're going to go over in a later example, we would choose to manufacture all Deercrest because would you rather make $65 for selling a unit or $50? If there was some kind of quantity constraint, we would make the Deercrest up to the limit of the quantity and only then start to make the Jordanelle. But we actually do have some constraints. So we have our first constraint, 3.5J plus 4D is less than or equal to 84. So this is our fabrication constraint. It takes 3.5 hours to manufacture a Jordanelle, 4 hours to manufacture a Deercrest, and there are only 84 fabrication hours available. Then we have our second constraint, which is our finishing constraint. So it takes 1 hour to finish Jordanelle, and it takes 1.5 hours to finish Deercrest, and we only have 21 hours available. Then we want to make at least twice as many Deercrest as Jordanelle. So this is the constraint in mathematical format. And finally, we can only make positive quantities or zero quantities. We cannot make negative quantities. So let's go on with how to do our linear programming by hand. So the first thing we're going to do is we're going to solve the first constraint, but we're going to solve it as if it's an equality rather than an inequality. So our first constraint is 3.5J plus 4D is less than or equal to 84. So the first thing that I'm going to do is I'm going to turn it into an equality, and then I'm going to try to solve for D because our equation is y equals mx plus b. So we want a y equals. So I have my equation now as an equality. So what I'm going to do is I'm going to subtract 3.5J from both sides. So now I have 84 minus 3.5J. Now I'm going to divide both sides by 4. So I get my Deercrest is 84 minus 3.5J. I take that answer and then I divide that by 4. Now the next step in the problem is to find 2 points on the line. So we could substitute any numbers in, but the easiest one is where 1 equals 0, then the term drops out, so all we have to do is the other term. So first let's do the easy one. Let's solve for J equals 0. So if J equals 0, this entire term, the 3.5J, drops out, and we have D equals 84 minus 0, which is 84 divided by 4 is 21. So the first point that we have is 0, 21, because remember, J is our x, and we always list x first. So we have our first point, 0, 21. Now, let's solve for D equals 0. A little bit more complicated, but still just pretty basic algebra. So substituting 0 in for D, we have 84 minus 3.5J divided by 4 equals 0. Now, since the 4 cannot equal 0, the 84 minus 3.5J has to equal 0. So if that happens, then J is 84 divided by 3.5. I just moved the 3.5J to the other side. Divide both sides by 3.5. And I get 24 as the answer. So my second point, because we're solving for D, we always list J first, is 24, 0. Because remember, the D was 0, D is second, and we solve for a J equals 24. So now we have 2 points on our first constraint line, 0, 21, and 24, 0. So now let's figure out the equation for our constraint line. So we need to find the line that passes through those 2 points. The first step is to find the slope, change in y divided by the change in x. So we take 21 minus 0, subtract 0 minus 24. We get negative 21 divided by 24, which is 0.875. So now that we've got the slope, we have our formula y equals mx plus b. We need to find that intercept. So right now our equation is d equals negative 0.875j plus I. I'm using I for the intercept. Now we have 2 points that pass through the line 0, 21, and 24, 0. So if I substitute in 21 and 0 or 24 and 0, then I can solve for the intercept. It actually doesn't matter which one, because you're going to get the same intercept because it's on the same line, but I solve for both just to prove it. So substitute either point to find the intercept. So first we'll substitute 0, 21 into our line equation. So D is 21, J is 0, so 21 is 0 plus I, so I is going to equal 21. Now let's say instead we substituted 24, 0, we get 0 equals 0.875 times 0.24 plus I, so I is still going to equal 21. Therefore, our equation of our first constraint line, D equals negative 0.875J plus 21. Now, we have to find the line for the second constraint. So, our second constraint is J plus 1.5D is less than or equal to 21. The algebra should be a little less difficult with this one. So, just like we did before, we turn it into an equality and solve for the y variable. In this case, our y variable is D. So, turn it into an equality. Move the j to the other side, so 1.5D equals 21 minus j. So, dividing both sides by 1.5, D equals 21 minus j, divided by 1.5. So just like before, we're going to solve for j equals 0 to find our first point. So we have D equals 21 minus 0 divided by 1.5. So we get the answer first, 14. So our first point is 0, 14. Next we'll solve for D equals 0. So we have 0 equals 21 minus j divided by 4. So once again, 4 can't be 0, so 21 minus j has to be 0, so j equals 21. So now our second point is 21, 0. So we're going to do the same thing. We're going to find the line that passes between 0, 14 and 21, 0. So, as I just said, find the line that passes through the 2 points that we just found on the line. The slope is the change in y over the change in x. So we take 14 minus 0, divide that by 0 minus 21, and we get a slope of negative 14 over 21. So now all we have to do is find the intercept. So we have our equation for the constraint line, d equals negative 14 divided by 21j plus I. So we're going to do the same thing. We'll substitute either 0, 14 or 21, 0. I'm going to substitute both just to show you that it comes to the same number, but you don't have to substitute both. One or the other would be fine. So first I'll substitute 0 and 14. That's going to be extremely easy. So I get 14 equals 14 over 21 times 0. That term drops out. So basically 14 equals I. So I equals 14. Our second one will substitute 21, 0. So 0 equals negative 14 over 21 multiplied by 21 plus I. So I is still 14. So we've got a slope of negative 14 over 21 and an intercept of 14. So our second line, oops, that says first line, but it should read second line, is d equals negative 14 over 21j plus 14. Now we need our third constraint line, but that is really easy compared to the other two. So our third constraint, we have to have twice as many deer crest as the J1 Jordanelle. So d minus 2j is greater than or equal to 0. We turn that into an equality. So d equals 2j is our third line. Now the next step in the process is to open Excel and graph those 3 lines. So now what we're going to do is we're going to graph the 3 equations and then see what parts are in the feasible region. So let me remind you of our 3 equations. From the first constraint, we have d equals negative 0.875j plus 21. Our second constraint, d equals negative 14 over 21j. So I'm just typing the labels. I'm not putting in the formulas, just to remind you of the formulas as I put them in. Plus 14. And then our third constraint, very easy, d equals 2j. So in column A, I'm going to put in my x variable. That's how Excel does charts, that the x variable is to the left. In this case, our x variable is the Jordanelle, so I'm going to put my j's in column A. Now, our largest intercept is 21, so I'm going to fill the numbers 0 to 21. I'm not going to start at 1 because I want our line to cross both intercepts, the x and the y intercept. So in cell A2, I'll type a 0 and enter, then type a 1 in A3, select both of them, and use the fill handle and drag that down to 24. You can go longer if you want, but what would happen is the chart would extend into the negative region, which we don't want. So in cell B1, I'm going to type constraint 1. Then I'm going to click on cell B1, and I'm going to use the fill handle to drag that out to columns C and D. So notice it automatically filled in constraint 2 and constraint 3. If I didn't want it to do that, I could tell it to copy the cells instead, but I like the fill series, so I'm going to leave that. So in column B, we're just going to calculate all of the D's for our J's. So we have our first formula, D equals negative 0.875J plus 21. So I'm going to put in the same formula, equals negative 0.875 multiplied by, you cannot assume the asterisk in Excel. Every time you multiply, you have to use an asterisk. So negative 0.875 multiplied by j plus 21. So I'm going to hit enter. I'm going to click on cell B2, and I'm going to double click that fill handle, and notice it goes down to 0. Now in cell C2, I'm going to put in the formula for our second constraint. We take j, multiply it by negative 14 divided by 21, and then add the number 14. So equals, open parentheses, I always like to, start again, equals, open parentheses, I always like to put the fractions in parentheses just to make sure that the multiplication is okay. So negative 14/21, close parentheses, so I have that fraction calculated first. Then I multiply that fraction times our j, which would be a2, and then add the number 14. So I hit enter, click on cell C2, and double click that fill handle, but I actually only want to go down to 0, otherwise my line is going to extend. You'll see what I mean later. So I'm just going to delete cell C24 to C26, because again, I only want to go down to 0. Now constraint 3 is very easy. D equals 2j. So all I have to do is take 2 and multiply it by j. Hit enter and copy that formula down. Now the next step is to graph all of our constraints. So I'm going to select the range A1 all the way down to D26, and I'm going to click insert, and then I'm going to choose a scatter chart, but I'm going to choose one of the ones with straight lines. So it doesn't matter, since it's linear, the one with straight lines or the one with smooth lines will look exactly the same. So we'll choose the one with straight lines, and I actually want you to see what I'm doing. So just like the book, I'm going to cut off the vertical axis at 30. So I'm going to click the vertical axis, right click, choose Format Axis, and have my maximum at 30 instead of 60. So close that, and now we can see our chart a little bit better. So what we need to do is we need to find the feasible region. So because all of our numbers have to be positive, let's start with the first one. We're not feasible down in this area in the negative, or out in this area or this area. So that's why I had our charts only go down to 0. Now you see why I had each one of them go down to 0. Now our second constraint is this one. Actually, that's our third constraint, I'm sorry, which is that we have to have twice as many deer crests as Jordanelle, and the feasible region is going to be on this side, because again, it has to be at least twice. So on this region to the left of this line, the D would be less than twice A, and on this side, the D is actually greater than twice A. Now let's talk about our other constraints. So to actually graph them, what I'm going to do is I'm going to click the background, make sure that I'm on the Design tab, and I'm going to change the chart type. So what I'm going to do is I'm going to choose a combo chart, and for constraint 1 I'm going to choose an area chart. For constraint 2 I'm going to choose an area chart, and then for constraint 3 I'm going to choose the clustered bar. So that's what my chart looks like, and I click OK. So anything in the blue region and below satisfies constraint 1. Anything in the orange region satisfies constraint 2. So anything in the blue region would satisfy constraint 1, but not constraint 2. anything in the orange region satisfies both constraints. Now we have 3 constraints, so what happens is this region that has the orange and the stripes, or the clustered bars, that is our region of feasibility. Any other one would violate one of our constraints, but this area right here satisfies all 3 of our constraints. Now I know this is a long video, but we're actually almost done at this point. So as I said, this over here is going to be our feasible area. So within our feasible area, the maximum and the minimum is going to be one of the corners. Because we have a triangular area over here, our optimal solution is going to be one of the 3 corner points. So it could be this point right here. Sorry for my bad drawing, but I'm not very good at this. It could be that point right there, or it could be 0, 0. So those 3 points in the 3 corners are the possible solutions. Well, this is a maximization problem. If we don't make anything, we have 0 profit. So obviously the 0, 0 is going to be our minimum, not our maximum. So I'm going to take that out. So what we have over here are these 2 points, the corner point, which is going to be our y-intercept. I can't write very well. And we have this point right over here that we're going to have to calculate. So now I'm just going to take all this distracting writing off of the worksheet. I could do it with erasing too, just get it off. Almost done. And I think there we are. Okay, so we have our 2 corner points. So this corner point is going to be the y-intercept. So basically when our j is 0, where the orange, which is constraint 2, is going to hit. So if we scroll up, we can see over here that when j is 0, for our first constraint, our intercept is 14. So we have our first point that might be a maximum. Which is basically 0, 14. Now I'm sorry, but we have a little bit more algebra to do to calculate our second point. So notice our second point is basically where constraint 2 crosses constraint 3. So what we're going to have to do is we're going to have to set the equation for constraint 2, negative 14 divided by 21j plus 14 equal to our second constraint, d equals 2j. So what we're going to do is we're going to set the 2 equal to each other. So I'm just typing in the formulas here like you'd write them on a piece of paper. So at this point I'm just using Excel as a typewriter, not a calculator. So I'm going to take negative 14 divided by 21j plus 14, and I'm going to set that equal to 2j. So now what I need to do is I need to solve for j. So what I'm going to do is I'm going to add 14 divided by 21j to both sides. So I'm going to get 14 equals 2j plus negative 14 divided by 21j. Oop, messed that one up. 14 over 21j. So, if I take 2j and then subtract 14 over 21j, well, 2 is the equivalent of 42 divided by 21. So if I take 42 minus 14, I get 28. So I'm going to get 14 equals 28j. So to solve for j, now for our second point, we have to find where our two constraint lines cross. So we're going to go back to our original equation. Notice for this point it's not on the blue line, it's on the orange line and the bars, so we're only looking at constraint 2 and constraint 3, not constraint 1. So what we want to do is we want to set constraint 2 and constraint 3 equal to each other. So going back to the PowerPoint just for a moment, we have here our three constraints. So our second constraint, j plus 1.5d is less than or equal to 21. And our third constraint, d equals 2j. So we're going to set those two equal to each other, and then we're going to solve. So scrolling back up to the top to solve for our second point, we're going to set j plus 1.5d equals 21. Start again. Now, to get our second point, we're going to have to solve a series of simultaneous equations. Now we don't care about constraint 1 because our ideal point doesn't cross on the blue line, but it does cross at the intersection of the orange line and our bar chart. So we're going to be looking at the intersection of constraint 2 and constraint 3. So we're just going to take a quick look at those. Constraint 2, j plus 1.5d, we're going to turn it into an inequality, equals 21, and d minus 2j equals 0, so d equals 2j. So I'm going to scroll up to L1, and I'm going to put in the formulas. So we had our first formula, j plus 1.5d equals 21, and our second formula, d minus 2j equals 0, or d equals 2j. So since d equals 2j, I'm going to substitute 2j in for d over here. So j plus 1.5, and now since d equals 2j, I'll just put in the 2j, and that should be a plus 21, not an equals 21. I'll fix that. Oh no, that should have been an equals 20. Damn it, fucking hell. Now to finally solve this problem, we have to find this point over here where constraint 2 crosses constraint 3. So in order to do that, we're going to solve constraint 2 and constraint 3 as simultaneous equations. So just to go back to the PowerPoint to remind you of the equations, and remember we don't need constraint 1. So we're going to solve j plus 1.5d equals 21, and d minus 2j equals 0, so therefore d equals 2j. Now, in order to find this corner, we're going to have to solve a series of simultaneous equations. We don't have to worry about constraint 1 because that is not involved in our intersection. Our intersection over here is the intersection where constraint 2 and constraint 3 equal each other. So just to remind you of the original formulas, constraint 2, j plus 1.5d, we turned that into an equality, so that equals 21, and d minus 2j equals 0, so d equals 2j. So I'm going to solve those two equations simultaneously. So in cell L1, just to remind you of the two equations, our first one, j plus 1.5d equals 21, and our second equation, d equals 2j. So now what I'm going to do is I'm going to substitute 2j for d in the first equation. So I have j plus 1.5, and here's the substitution, d equals 2j, so I'll just put in 2j there, and that expression is going to equal 21. Now 1.5 multiplied by 2 is 3, so now we have j plus 3j equals 21. So we have 4j equals 21, and finally, after all of that, j is going to equal 21 divided by 4, which is 5.25. So j is going to equal 21 divided by 4, and to calculate that out for you, equals 21 divided by 4 is going to give us 5.25. So now that we've solved for j, we have to solve for d, but that's very easy because d equals 2j. So our d is just going to equal twice 5.25. So our d is going to equal 2 times 5.25, 2 times j, which is 10.5. Okay, so now we have two possible profit points. This corner is 0.14, and this corner over here, this bottom corner, is 5.25, 10.5. So now the last step in the problem is to see which of these 2 points gives us the higher profit. So we either make 14 Dardanelle and Deercrest and no Jordanelle, or we make 10.5 Deercrest and 5.25 Jordanelle. So let's see which is going to give us the bigger profit. So going back to the PowerPoint for a moment, if you remember our profit equation, 50j plus 65d. So let's look at point 1, 0.14. So our first point is 0.14. So we would take 50 multiplied by 0, and then we're going to add 65 multiplied by 14. So our profit at point 0.14 is 910. Now we have our second point, 5.25 and 10.5. So let's calculate the profit for that point. So our profit for that point equals 5.25 multiplied by 50. We make a profit of 50 for each Jordanelle, and then we add 10.5 multiplied by 65 because we make a profit of 65 for each Deercrest. So we get a profit of 945, which after all of that work, what is this, like 33 minutes or something on this video, we finally found our optimal point, 5.25 and 10.5. The only problem with this solution is we cannot manufacture 5.25 Jordanelles. Now 6 is not possible because if we go out to 6 in this solution, we're going to be out of that feasible area. We can only go up to 5 where it actually crosses that line. So let's take a look at our third possible point. So since we can't manufacture 5.25, we would have to go to the next lowest number. So our third possible point is 5, 10, because D is to J. Now I'm going to take equals 5 multiplied by 50 and add to that 10 multiplied by 65, and we get a profit of 900. And we actually see that using whole numbers, our profit is lower. So, based on the linear programming, our profit maximizing point would be 5.25 and 10.5 in that, again, that feasible area. But we cannot manufacture 5.25. So it looks like our most profitable point is to manufacture all Deer Crest, 14 Deer Crest, and 0 Jordanelle, and then all of our constraints are satisfied.